So basically, the formulas we're going to learn are going to be divided into the shapes that we're talking about. So today we're going to focus on just the prisms and the cylinders. If you remember from last Thursday, prisms and cylinders have two parallel bases. So we're grouping them together because they're very similar to each other. So when we're talking about our formulas, I'm going to have you memorize a formula that works for both the prism and the cylinder. So again, prism could be something like a rectangular prism. Just draw a little example up here on the board. Or a cylinder, remember, looks kind of like a soup can. So prisms and cylinders have parallel bases, and we're going to use the same formulas for them. So we're going to have a formula today we're going to learn for volume and a formula that we're going to learn for surface area. And then Wednesday, we will look at the pyramids and the cones. Why do we group those together? What do they have in common? Okay, they come to a point. They have more than one vertex depending on the base, but they do all come to a point. So I'm going to go ahead, if you want to, on your formula sheet and write that down. When we get there on Wednesday, we'll learn two formulas for pyramids and cones. We'll have one for volume and one for surface area. And then on Friday, we'll talk about the spheres. They'll be special. We'll just talk about them all by themselves because a sphere is completely circular. It has no faces, no edges, no vertices. So it's kind of different than the other ones. And again, we'll learn a surface area formula, a volume and a surface area formula for the spheres. So how many formulas is that? 6. And how many did I say we were going to learn? 7. So the 7th one is going to come in today. I probably should have put it up here. That's going to annoy some of you that are very detailed, and I'm sorry about that up there, but you can add it down here at the bottom. We're going to go ahead and fill it in today when we get there. Even though the prisms and the cylinders have a special formula for volume and surface area, we're actually going to learn that a cube, which we also called what's another name for cube? Hexahedron. A square is only 2-dimensional. Our shapes are 3-dimensional now. Cube, which is made up of squares, or we also called it a hexahedron. We're going to talk about a special formula for its volume. And I'm pretty sure that's all that I put on the formula test, even though it has a special formula for surface area as well. So let me double check. I don't want to lie to you. I thought I had it laid out. There it is. Okay. Yes. So the only one I'm going to put on the formula test was the volume for a cube or hexahedron, but it also has a special surface area formula as well that you can use if you want to. But we are going to learn a special volume formula for it. So that'll be your 7 formulas. 3 of them we're going to learn today. Okay. So when we're talking about surface area, what does that mean? What's surface area? Okay, the area on the surface. So if I'm looking at these shapes, what's the surface? The outside. So we're talking about, in this case, we're talking about this square prism. It would be the area of the 2 squares and then the area of the 4 rectangles. And what you probably learned, because I have 3 boys who went through Siloam Springs School District, and all 3 of them at this point have probably learned about surface area before they ever hit geometry. And most of the time when teachers teach it at the lower levels, they teach you to find the area of each square and then the area of each rectangle and then add those together. Is that how you guys have learned about surface area? Okay, we can do it that way, and if all else fails, by all means, work it that way if that works for you. But we're going to learn a special formula because now that we're in geometry, they're not always going to give you all the information you need. Or they may give you the surface area and ask you to work backwards and find the height or find the perimeter or find the area of the base. And the formula will help make that faster. Okay, so surface area is going to include all the area that would cover the outside of this. If we wanted to paint this shape, where would we put the paint? Volume is talking about what? How much you can fit on the inside. So some of these have little open circles, you'll notice, open spots, open places, so you can actually fill it up and talk about what fits inside the shape. You can pour sand or water or whatever you want to in there and talk about the volume. Volume is how much fits inside your shape. Again, I'm going to teach you a formula that will make that a lot easier. They'll have the same volume formula and the same surface area formula. Hardest part is sometimes the lateral area, and I think we barely talked about this on Thursday. Did we talk about the lateral faces versus bases? Okay, so remember the bases are your two parallel congruent shapes. The other four faces are your lateral faces. Sometimes the problem is going to ask you for just the lateral area, not the surface area. If you think about a cylinder, that would be this curved surface, but not the two bases, right? Are you guys with me? So lateral area would be the area except the bases. Every time. The area except the bases. And so in real life, like a soup can label only goes around the lateral part. It doesn't go on the top or the bottom. Depending on what you're dealing with in real life, you may only want the lateral area, not the surface area. Or maybe you want the volume. Maybe you're trying to figure out how much will fit inside your shape. So those are the ideas we're going to talk about today. In corporations and companies, they deal with area and volume all the time. When they're trying to minimize the cost for packaging, they're worried about how much volume can they fit inside the packaging, but using the least amount of material because they want to save the most money that they can. So if you go into business and go into some sort of aspect of that, you'll be talking about surface area and volume a lot. So it really is applicable. Okay, so let's talk about our formulas and figure out how to find these surface area and volumes. I already talked about what volume is. It's what fits inside. The one thing we didn't mention is what will your units be for volume? Cubed. It'll be units cubed. So notice it says the number of non-overlapping unit cubes, meaning that your answers will always be units cubed or inches cubed or feet cubed or miles cubed, whatever it is. So we're talking about volume. Before we get to the actual formula, we want to talk about this guy, Cavalieri. Cavalieri's principle basically says that if you have two shapes, they can be right prisms or oblique prisms. Did we write that down in our notes on Thursday? So obliques are the slanted ones, right ones are the ones that are not slanted. Cavalieri says if you have two shapes and they have the same height, and if you were to cut the shape at any level, like say 2 inches up and 2 inches up, if you were to cut it and look at their cross sections, if they have the same cross-sectional area. So let's say I cut 2 inches up, cut the shape, look at the square, I find the area, it's 5 inches squared. I go to my cylinder, I cut it 2 inches up, I look at the area of that circle, and it's 5 inches squared. If they have the same height and the same cross-sectional area at every level, then your two shapes will have the same volume. That's what Cavalieri says. If two three-dimensional figures have the same height and they have the same cross-sectional area at every level, 2 inches, 3 inches, 4 inches, 5 inches, anywhere you cut it, the area of that shape is the same as the area of this shape, then they will have the same volume. And the reason for that is because of the formula for volume. The formula for volume is just area of the base times the height. Capital B, write this down in your notes. Capital B stands for area of the base. And I'm going to be super picky that you use a capital B because that's different than a lowercase b. Lowercase b is a one-dimensional base length. Capital B is a two-dimensional area. So capital B means area of the base. So to find the volume, you just find the area of the base, and then you multiply it by the shape's height. Notice when it's oblique, where is that height? It can be outside the shape. It can be inside as well. They could draw it like this, as long as they're drawing it perpendicular, but typically in a picture they'll show it outside if it's slanted, okay? Otherwise, your height is just the perpendicular distance between the bases. I would write that down in your notes. H is the perpendicular distance between the bases. Your height is always going to be perpendicular between your two bases. Capital B is the area of only one base. Only one base. Okay, so on your formula sheet, you're going to write down volume for a prism or a cylinder is just capital B times H. Capital B is going to change based on your base. If your base is a square, you'll use the area formula for a square. If your base is a circle, you'll use the area formula for a circle. That's why all those formulas we learned last chapter are going to come into play in this chapter. Okay? So for example, if we have a rectangular prism, what is the base shape of a rectangular prism? What is the shape of a rectangular prism? Rectangle. What's the formula for the area of a rectangle? Base times height. They're going to go back to now length times width when they get to three-dimensional solids, because the H for height is going to represent the actual height of the prism. So they're going to call it length times width for the area of the base, because it's just a rectangle. And then you have your formula, volume equals area of the base times the height. So if it's a rectangle, that's length times width, and then you have your height. You could come up with a new formula for every prism, but I don't want you to have to do that. So what we're going to do is we're just going to use capital BH for volume, and then over to the side we'll find the area of our bases just like we did last chapter, and then we'll plug those numbers in after we find them. So the area of the base would be the length times the width, and then we would multiply that by the height of our prism. The only one I'm going to make you memorize separate is the cube. So the cube or the hexahedron. So what is the shape of the base of a cube? Square. What's the area formula for a square? Side squared. So here's the deal. Capital B equals S squared. Corbin, you with me? If my volume is capital BH, and we just said capital B is S squared, what's the height of the cube going to be in this picture? S. So this is our height. This was our base. So we plug in S for the height. What is S squared times S? S cubed. That's the only special one I'm going to make you memorize. Every other shape you can just find the area of its base, plug it in, multiply it by its height. But the reason I'm going to make you memorize S cubed is because sometimes they're going to give you the volume and ask you to go backwards and find the side length, and you won't be able to do that as easily if you don't have this formula. Okay? It's not hard if you think about squares or S squared, and volume is cubed, so the volume of a cube is just going to be S cubed. Okay? Yes, sir.
The area of the base
Mm-hmm.
for the rectangular prism, will we have to multiply the bases by 2?
Nope. It's just capital B's area of one base. You only use one base. So good question. I want to make sure everybody's clear. Capital B means area of one base, and that's all you're using for your formula, the area of one base times your height. Even though it has two bases, you only calculate the area of one base and multiply that by the height to get the number of cubic units that would fill it up. Okay? All right, let's look at some problems for volume. Before we get there, let's talk about our surface area. This is not in our textbook. I need to warn you about that. This book does not talk about surface area until you get to spheres. They assume that you learned surface area back in middle school, which you did, but not to the extent that they're going to expect you to use it. It's very basic what you learned. Probably most of your surface area problems, they had you lay it out like this and find the area of every piece and add them all together. Would you agree? Okay, the book's going to get much harder on surface area. So that's not going to work all the time. So I pulled this from another site and just kind of stuck it into our notes. So it's got some things I'll have you fix just a little bit, but for the most part it was pretty good. Surface area, we already said, is adding all these areas together. I do want you to add to your notes this part about lateral area, and we're going to fix this over here in just a second where it says TA. We're going to change that. Okay? But lateral area, I talked to you about just a few minutes ago. Lateral area will be the area of everything except what? The bases. So you'll take away the bases, and you'll just look at the area of everything else. So the lateral area is the sum of the areas of the lateral faces. No bases. So when you're thinking lateral area, just think everything except the bases. Okay? The formulas that you're going to need to memorize are only for surface area. Surface area is what we're going to change here. The book that I copied this from said TA for total area, but we're going to use SA for surface area. And our book, I think, only uses the letter S for surface area. So if you see S, just think that means surface area. The SA, surface area. The surface area is going to equal the lateral area plus the two bases, right? And the lateral area formula is going to be capital P. That looks like a lowercase p. Make sure you make it a capital P. Capital PH. So the formula for surface area will be capital PH plus 2B. So over here on your formula sheet, you're going to write down surface area for any prism or cylinder is capital PH plus 2 capital B. Now we already talked about what capital B stands for. What does capital B stand for? Area of one base, which is why we're going to multiply it by 2 because we have two bases. Capital P, add in your notes. Capital P, what do you think that stands for? Perimeter, but it's going to be the perimeter of only one base. Perimeter of the base. Only one of them. Perimeter of the base. So you're going to look at your shape and you're going to find the perimeter of your base and you're going to multiply that by the height of your prism. Remember, H stands for the perpendicular distance between your bases. So perimeter of the base times the height plus 2 times the area of the base. Okay, one more time. Lateral area is everything except what? The bases. So again, I want you to add this to your formula sheet. What part of this formula is the lateral area? The capital PH. So on your formula sheet, I would circle this part and write, this is my lateral area. It's not another formula you have to memorize because it's in your surface area formula. If you want to find just the lateral area, don't include the bases. If you want to find the whole surface area, include the bases. Does that make sense? Okay, we're going to see. We're ready to try some problems. Okay, so first problem says find the volume and surface area. So make sure that you're doing both. Biggest mistake I see on the homework is students only finding one thing or the other. Volume and surface area, round to the nearest tenth if necessary. Number one rule today and Wednesday and Friday. Start with writing your formula. My advice, once you write your formula, go over to the side and find the things you need. Find capital B separately. Don't put it in your formula. Do it over to the side because you're going to need it for volume and surface area. So it's going to help you if you don't get confused and put it in your formula. Find your perimeter separately. Okay? So I'm going to show you what I would do if I were you because these problems are going to get harder. Pay attention to me right now. Do what I'm doing. Don't just assume you've got this. It's easy because they do get harder, okay? So first volume. What's our formula? Capital BH. Thank you. Then I would go over to my paper and I would write capital B equals, and I would do that separately on my paper so that when I'm ready to find the surface area, I already know what capital B is. If you start putting it in your volume formula, you're going to make a mistake later and put the whole volume in for B. I promise you, I see it every year. So don't do that. Capital B means area of the base. What is our base in this shape? I don't see any squares in this picture. Be careful. Squares have to have the same dimensions. It's a rectangle. You have two options. This is a 13 by 3 rectangle. This is a 5 by 3 rectangle. And then the front is a 13 by 5. So you have three options, actually, of what could be your bases. It could either be the top and the bottom, it could be the left and the right, or it could be the front and the back. And if you're dealing with volume or surface area, it won't matter which ones you call your bases. Since it's rectangular, it can be any two rectangles. The only time it would matter would be if we were finding lateral area. Then you would have to know specifically which ones do they want my bases to be, because then we wouldn't include the bases, so it would make a difference. Okay, so what do you guys want to call the base? Top, bottom, left, right, front, back. Okay, I heard more people say top and bottom, so I'm going to go with the bottom. This is going to be our base, which is what shape again? Rectangle. So what's the formula for area of a rectangle? Base times height or length times width. Okay, what is the length or base in our shape? 13. What's the width for the base shape? 3. What is 13 times 3? 39. So now we know the area of the base, and anytime we have to use capital B, we'll already have our answer as 39. Okay, if we use the top and the bottom as our bases, what's the height then of the prism? 5. Be very careful. Again, it's always the distance between the bases. So if you're using the top and the bottom, 5 is your height. Be very, very careful. So this is your H. So now we're going to plug it in. 39 goes in for B. 5 goes in for H. Multiply it on your calculator. What's the volume? 195. What are the units? Centimeters cubed. Put V equals for your final answer so that you'll separate that from when you find surface area in just a minute. Okay, now we're going to go to surface area. What's the formula for surface area for any prism or cylinder? pH plus 2B, capital pH plus 2 capital B. We already know what capital B is. What's capital B? 39. And if we do it over there separately, we won't have to find it or figure it out later. We'll already have it separate over there. We already know what H is. What's H? 5. So what's the only thing we need to find now? The perimeter. Be careful. Remember, P stands for perimeter of only the base. Perimeter of only the base. So we called this rectangle our base. How will we find the perimeter of that rectangle? Okay, so Gavin said we're going to have 13 plus 3. Don't forget the side over here is also 13, and the side over here is also 3. So he said 13 plus 3 plus 13 plus 3. We could also use the formula 2 base plus 2 height if you want, but that's totally fine to just add all the sides together. And what is 13 plus 3 plus 13 plus 3? Careful. 32. So now we have our perimeter is 32, and we're ready just to plug it all into our formula here. So 32 goes in for P. What goes in for H again? 5 plus 2 times what goes in for capital B? 39. And again, if you'll just kind of find those things over to the side, it makes it so much easier when you get to surface area just plugging them in. All right, what's 32 times 5? 160. Plus, what's 2 times 39? 78. They are like terms, so we can add them together. So what's the surface area total? 238 units. It's area, so it is centimeters squared. And notice, units are going to be really tricky this chapter. So be really careful. Volume should be cubed. Surface area should be squared. Easy enough? Okay, they're going to get a little harder, obviously, but so far, so good. Again, find capital B, find capital P over to the side. It'll make your life so much easier. All right, and real quick before I go on, look at this with me one more time. What part of this formula was just lateral area? pH. So how much is the lateral area in this shape? 160. So this would be our lateral area if they asked us for just the lateral area. We just wouldn't include the bases, the 2B. All right, look at the next shape. What shape do we have? Cube, and notice there's no picture. You can draw a cube if you want to, but I don't know if you'll need to. What does it want us to find? Just the volume. What's our special formula for a cube's volume? Side cubed. Makes this really easy then. What do they tell us that the side length is? They say the edge length is 15 inches. Remember that. Remember that the edge of a cube is the side length of your cube. So that's what this S stands for, is the edge length. So we're just going to plug in 15. Now, do you know where the cubed button is on your calculator, or how to do 15 cubed? Okay, there's two ways you can do 15 cubed. One way is to type in 15 and then use the little caret symbol and then type in 3. Most of you probably know that way. Let me pull up my... Or you can do 15 times 15 times 15. That's the longest way. Let me pull my calculator up because I want to show you two things that are going to be really helpful if you didn't know. Sorry, it's taking just a second. Okay, so on your calculator, I'm going to assume everybody knows to do 15 and then the little caret. Come on, Ashley. 15 and then the little caret button and then 3. Enter. Everybody okay with that? Okay, or you could do 15 times 15 times 15. But there's also another place where the little cubed button is. If you type in 15 and then go to math. Everybody go to math with me? Where's the little cubed button there? Number 3. It's not any faster to do it that way, but there's another button that's in the same screen that you're going to need later. So I wanted to show you where this is at the same time. So first of all, number 3 is what we could type in if we wanted to cube it. And notice we get the same answer. But sometimes they're going to ask you to go backwards. So let's say this problem actually said the volume of a cube is 3,375 centimeters cubed. What's the side length? So what if they wanted us to go backwards? Well, if they wanted us to go backwards, we would use our formula. What's the formula for volume of a cube? S, careful, cubed. And that would equal this 3,375, right? What's the opposite of cubing? Take the cubed root. It's not called a square root when it's a cube. So you would take the cubed root, which means you put a little 3 right here. Take the cubed root, put a little 3 right here. Then on your calculator, where is that cubed root button? Okay, you go to math and it is number 4. So you can type in number 4 first and then type in that 3375 and hit enter. And it takes you backwards and gives you 15. And that's why I'm making you memorize this special formula, because it's super easy then when they ask you to go backwards. You just take the cubed root. Okay? Questions there? All right, so back to our problem. Our problem said what was the volume, and we figured out that 15 cubed was 3,375. What are our units? Inches cubed. Every time ask yourself, are you finding volume or area? Or are you just finding a measurement like side, length, width, height? So that determines what your units are. All right, any questions on cubes? Okay, let's get to some harder ones. What do we have here? Hexagonal prism. And that's probably where the most of you that struggled with chapter 10 struggled mainly with hexagons, octagons, heptagons, decagons. So we have to find the volume and the surface area of this regular, that's key, because that means the base shape is a regular hexagon, of this regular hexagonal prism. We're going to round to the nearest tenth if necessary. So let's start with volume. Be careful that you're answering both parts of the question, though, so later you'll have to do surface area. What's the formula that we're learning today for volume? Capital BH. The only thing that changes is what is the B. Depends on the shape of the base. So what is the shape of our base? Hexagon. We've got two options to find the area of a hexagon. So I'll just take majority vote. One way to find the area of a hexagon is what formula? 1/2 apothem times perimeter. There was a shortcut that worked only for the hexagon. What was that shortcut? Okay, S squared, square root of 3 over 4 found the area of one equilateral triangle, and then times 6, because a hexagon is made up of 6 equilateral triangles. So raise your hand if you would prefer to use the shortcut 6 equilateral triangles. Hands down, raise your hand if you would rather do 1/2 apothem times perimeter. Okay, guys, I'm going to do the 6 equilateral triangles for this one. If we end up with another one later, I'll work it the 1/2 apothem times perimeter way. 6 equilateral triangles is really the easiest. So if you can start to memorize that, it's going to make it so much easier. So, area of the base, since it's a hexagon, we can do 6 times the area of an equilateral triangle. So that's going to be 6 times S squared, square root of 3 over 4. Look at the base only. What is the side length of the hexagon? 9. So what's going to go in for S is 9. So I have 6 times 9 squared, square roots of 3 over 4. Okay, we're going to wait to type in the square root because this is not our answer. Let's go ahead and simplify everything else right now. So on your calculator, go ahead and do 9 squared. What's 9 squared? 81. Divide it by 4. And then what do we want to do after we divide it by 4? We don't want to type in square root of 3 yet, so we want to multiply it by 6. So go ahead and do 9 squared divided by 4 times 6, and we're going to leave square root of 3 at the end of our answer. So what is 9 squared divided by 4 times 6? 121.5 exactly, square root of 3. Is everybody okay with just simplifying all of that out front? Corbin, I'm worried about you. You're not taking any notes. Okay, we're not taking these notes. Are we all good so far? Okay. All right, so then look at your picture. What's the height of the prism? 12. Remember, the definition for height is the perpendicular distance between your two bases. So 12 is the height. It is not always vertical. If this were laying on its side, the 12 would be on the bottom. So just be really careful. Okay, let's plug it in. So we have 121.5 square roots of 3 for the base times 12 for the height. We could leave this exact. Notice it says round if necessary. We could leave it exact. We could just type in 121.5 times 12 and leave the square root of 3 at the end. So let's go ahead and do that first. What's 121.5 times 12? 1,458, and then we would put square root of 3 on the end. And our units would be feet cubed. Or we could type it all in and round it, so let's go ahead and do that too, just so you'll have it in your notes as well. So if you multiply that times the square root of 3, what do you end up with? Nearest tenth. Somebody agree with Peyton? 2,525.3 feet cubed. So either one of those would be our answer for volume, depending on if you left it exact or you rounded. Questions so far? Okay, let's go to surface area, part B. Surface area becomes easier once you've found volume because you already know what capital B is. You already know what your H is, so you only have one other thing you have to find. What's the formula for surface area? Very good. pH plus 2B. We already know B, we already know H, so the only thing we have left to find is P. And what did P stand for again? Perimeter of the base, only the base. So if we look at our base shape, how are we going to calculate perimeter? It has 6 sides, so we're just going to do 6 times the length of each side, which is 6 times 9. What's 6 times 9? 54. Notice how I'm finding everything separate from my formula. The reason I'm trying to model that for you that way is because then I can give you partial credit. If you make a mistake on your base, but you don't make a mistake on your perimeter, and you had the formula correct, I can see where you went wrong and give you some partial credit. If you just start plugging all these numbers into your formula, I'm not going to understand exactly where you went wrong as easily. So find your things separately and then plug them in over here. So we have P is 54. The height was what again? 12 plus 2 times, and what did we get for area of the base? 121.5 square roots of 3. Much easier to see if you've done it separately over here than if you've just plugged it all in under the formula. Let's go ahead and simplify this. What's 54 times 12? 648 plus, what's 2 times 121.5? 243, and then we still have that square root of 3, right? Okay, I want everybody to stop once you get that written down, and let's talk one more time about how to deal with square roots. Remember to treat your square root like a variable. Can you add 648 plus 243x? No, you cannot add then 648 plus 243 square roots of 3. You cannot add the 648 and the 243. Is everybody with me there? But you can if you want to type it into your calculator and round. So this would be as far as we could go if we were leaving it exact. Add your units. Feet what? Careful, we're finding surface area. Squared. Or if you want to approximate it on your calculator, you could then type it in and round to the nearest tenth. So do that and tell me what you get. Andy, question? Because the area of the base capital B was 121.5 square roots of 3. And then we plugged that in for capital B and multiplied it by 2. Does that make sense? Okay. And then you understand the 243 came from 2 times 121. Okay. So type this in. Tell me what you get to the nearest tenth. 1068.9? 1068.9 feet squared because it's surface area. And again, on your answers, make sure you're putting SA equals and V equals so I'll know which one's which when you're doing your work. Any questions so far? Okay, we're going to try one more that's a little harder, and then we're going to switch to the cylinders. So, go to this next one. And notice, first of all, what do you not have? A picture. So sometimes they're not going to give you a picture, and you've got to draw one. So look at it and decide what shape do we need to draw. Triangular prism, but it is a special kind of triangular prism. It is a right triangle. Notice here it says right triangle. So we need to draw a right triangular prism. So I would usually start with just drawing a right triangle on my paper. To me, that's a little easier. And then remember that prisms are made up of 2 bases with a bunch of what shapes? Rectangles. So once you draw your right triangle, then you can extend this out to make it a prism. And then, oops, I don't know why I'm dashing that. That should not be dashed. And then you're going to use dashes to get that third dimension. Where should that? What did I do wrong? That's right. Okay, are you guys with me? And maybe you won't even need the entire picture, but if you do, draw it. If you're not sure what it looks like, look in your book. There's probably a picture of a prism, triangular prism in your book. And if that's not good enough, then just Google, right? Triangular prism, look at a picture, draw it, okay? All right, let's label it. So it says find the volume and surface area. So again, two things. Of a triangular prism with a height of 9 yards and a base that is a right triangle with legs 7 and 5. Okay, where I usually see students make the biggest mistake is where it says height of 9 yards. What has a height of 9 yards? What in this problem has a height of 9 yards? What shape? The triangular prism. The prism has a height of 9 yards, not the right triangle. The prism has a height of 9 yards. Height, by definition, is the distance between your bases. So in my picture, where's that 9 yards going to go? The horizontal distance. This is my height, the distance between the bases. Are you guys with me there? Then it says you have a base that is a right triangle, and that base has legs 7 and 5. So where's the 7 and the 5 going to go? Okay, on the right triangle, but on the two legs that make the right angle. So one of them is going to be 7 yards, one of them is going to be 5 yards, and it won't matter which one's which. Okay, so hardest part there was figuring out what's my picture look like and how do I label it, and then we can start working the problem. So volume today, what's my formula? Capital BH. And we're going to start by finding the capital B. We said that, let me slide this over. The base is what shape again? A right triangle. What's the formula for the area of a triangle? 1/2 base times height. In a right triangle, what are your base and your height? In this picture, it's going to be the 5 and the 7 because it's always the two legs. The base and height of a right triangle are always your two legs. So we'll have 1/2 of 5 times 7. That's a 5, not a 6. Sorry, it looks like a 6, but it's a 5. So if you're looking up here, I'll see if I can erase it. Yeah, that's a 5. All right, what's 1/2 of 5 times 7? 17.5. Okay, and then what's the height of the prism? 9. So be really careful. Again, this H is not the height of the base. It's the height of the prism. And again, that's where I see a lot of trouble is with the height. Height is the distance between the bases. So in our formula, we'll have 17.5 times our height, which was 9. What do we get for the volume? 157.5 yards cubed. Volume. Questions on the volume? Seriously, everybody's good, even my quiet people that are not saying a word? Okay. Surface area. What's our surface area formula? Okay. The formulas, we just keep writing them down and keep using them. And the more you write them, the more you're going to memorize them. So write them down. Capital PH plus 2B. We already know what capital B is. We already know what H is. So the only thing we have to find now is P for perimeter. So let's find the perimeter. This is going to be the harder part. How do you find, first of all, what are we finding the perimeter of? The base. What's the shape of the base? The triangle. How do we find the perimeter of that triangle? Very good. We're going to have to find this missing piece, the hypotenuse, by using Pythagorean theorem. Once we find this missing side, what are we going to do to find the perimeter? Before we multiply by anything, what are we going to do to find the perimeter of this triangle once we find this length? We're just going to add them all together. Okay, perimeter is just the sum of the sides. So we're going to do Pythagorean theorem to find x. So my Pythagorean theorem, a squared plus b squared equals c squared. What goes in for a? 7 or 5, doesn't matter. What goes in for b? 5. Yep, whichever one you didn't just use. And we're looking for c, which I called x. What's 7 squared? 49. What's 5 squared? 25. Together, those are going to equal x squared. What's 49 plus 25? 74 equals x squared. What do we do then to solve for just x? Square root. So we have the square root of 74. So that's not our answer, so we're not going to plug that into our calculator yet. Remember that we don't want to round until the very end. So perimeter will be 7 plus 5 plus square root of 74. We can simplify that just a little bit. What could we add? 7 and 5, what's 7 plus 5? 12, so we have 12 plus the square root of 74. Remember that you cannot add those because they're not like terms. So now we're ready to plug that into our formula. Okay, so surface area becomes, I don't have a whole lot of room here, surface area becomes 12 plus the square root of 74, that's our perimeter, times the height. What's the height again? 9. Be very careful. Remember, H stands for the height of the prism, not the height of the base. So times 9 plus 2 times, what was capital B again? 17.5. Everybody's with me? Okay, let's simplify. Be very careful right here with P times H. Either you have to distribute this 9 to both if you're trying to leave it exact, or you have to type it in parentheses and then round. So be very, very, very careful. It didn't say to round, but I'm not going to make this super difficult for you, so let's just type it in on our calculator and round to the nearest tenth, because that's what I'll ask you to do on the test anyway. So on your calculator, let's make sure you're typing this in correctly. You're going to do that 12 plus the square root of 74. If I were you, I would just type that in first and hit enter. I'm going to pull up my calculator. Just going to bring this over here a little bit, maybe. Okay, so I'm going to type in 12 plus the square root of 74 and hit enter. And then what am I going to do with that number? Multiply it by the height 9. Hit enter. And then what are we going to do with that? Add 2 times what? 2 times 17.5. Oops. 2 times 17.5. And hit enter. And do you get about 220.4? Awesome. Okay. Was it 222 or 220? 0.4? Units? Yards squared. Okay, that's where it gets a little harder when you have to calculate things like using Pythagorean theorem to find your perimeter. But again, if you'll just go step by step, find your base, find your perimeter, find your height separately, then it's easy to just plug it into the formula. On your calculator, okay? Can I see what you typed in so I can see where you went wrong? Let's see. You didn't end your square root, okay, but then you did it again. Okay, but you only multiplied the square root of 74 times 9. The whole thing is supposed to be times 9. That's why when I typed it in, I hit enter before I hit times 9. Otherwise, you've got to put it in parentheses like it is in your formula. Okay, so try it again. Anybody else having trouble with their calculator? Because this is all great, but if you can't type it in right, it doesn't help you. Degree and radian will only affect your answer if you're dealing with sine, cosine, or tangent. So if you're not typing in sine, cosine, or tangent, it does not even affect your answers at all. Keep it in degree mode if you are typing in sine, cosine, or tangent. Good question. Okay, we're going to skip the next one and go on to cylinders. You're going to see that they're pretty easy. Cavalieri's principle works with cylinders as well, so just a reminder that if they have the same height, the same cross-sectional area, they'll have the same volume. Doesn't matter if they're slanted or not. The volume formula is still the same, capital BH. The only difference is now we're going to have circular bases instead of triangular bases or hexagonal bases. And so that capital B formula will change to the area of a circle. But again, I don't make you memorize a separate formula. We just change B for whatever base we have. Surface area is going to be the same as well. We'll just change our perimeter to the circumference of a circle because that's the perimeter. So we're going to jump right in and look at finding the volume and surface area of this cylinder. So start with volume with me one more time. What's our formula today? We should have it down by now. What's volume? BH. Capital BH. Volume is BH. All right, so we're going to come over here and we're going to calculate the capital B. Capital B means area of the base. What base shape do we have? Circle. What's the formula for area of a circle? Pi r squared. All right, look at your picture. Do they give us the radius? No, what do they give us? Diameter. If the diameter is 18, what's that going to make the radius? 9. Half of 18 is 9. So now we have pi times 9 squared. Notice the directions say give your answer in terms of pi and rounded to the nearest tenth. So we're going to have two answers for each one. Okay, so let's go ahead and do it. What's 9 squared? 81. Keep your pi at the end. Don't round it. Leave it in terms of pi. All right, so we found our area of our base. What's our height of this cylinder? 14. Remember, your height is going to be the perpendicular distance between your bases. And since it's oblique, the height's outside the cylinder. So now we just plug it in. We have 81 pi for the area of the base, and the height is 14. Don't type in pi. It said leave your answers in terms of pi. So just do 81 times 14. What do we get? I heard 1,134 pi. Somebody agree with Peyton? Okay. And what are the units? Inches cubed. Left in terms of pi, that would be one of our answers. Then it said to round to the nearest tenth. So you can take that number and multiply it by pi. And tell me what you get. I heard 3,562.6. All right, and the units still are inches cubed. So just write your answers both ways if it tells you to. Circle both of them so it's easy for me to find and check your work. Okay, and then again, surface area will be easier because we've already found capital B and we've already found H. So the formula again for surface area, no matter whether it's a prism or a cylinder, pH plus 2B. So only thing we need to find is what? Okay, capital P, which stands for perimeter, but since it's a circular base, our perimeter is not really called perimeter, it's called circumference. And what is our circumference formula for a circle? Pi times diameter, or, which is pi d, or 2 pi r. And it doesn't matter. They gave us the diameter, so it's probably a little easier just to do pi d and plug in 18. So the circumference is just 18 pi. Are we okay with that? Okay. So now we're going to just plug these numbers in and try to leave it in terms of pi. So that's going to be the harder part maybe for you. Plugging in for P is 18 pi. What's going in for the height again? 14, remember that perpendicular distance, plus 2 times, and what's going in for capital B? 81 pi. And again, if you'll do that separate over to the side, it's really easy just to plug it in, 81 pi. Now, go ahead and multiply the things that you have out front that you can multiply. So what's 18 times 14? What is it? 252 pi. Don't forget your pi. Plus, what's 2 times 81? 162 pi. And notice they both have a pi. So you can add them. If they didn't both have a pi, you could not add them. But they do, so go ahead and add them, and what do we get? 414 pi units, inches squared. We'll circle that because it said leave it in terms of pi. And then we'll go ahead and type that in times pi, rounded to the nearest tenth. (1,300.6). Somebody agree? All right. Inches squared. So that is what I meant when I started out today and said this week's going to be a little brutal because it becomes long in the process. That makes the homework longer, and it's going to get harder even on Wednesday. So Wednesday isn't going to be hard. It's just going to be harder. Okay? All right. So any questions on cylinders? Okay, I'm going to look real quick. Can I see your notes? And see what we haven't done as far as cylinders go. Okay, we need to do the next 2 problems, and then we'll talk about composite shapes. Okay? Mrs. Lashley? Yes, ma'am. I have him on B days. Yes, ma'am. Sorry. No problem. Bye-bye. Okay, here we go. Quickly. All right. This is one. You guys with me? This is one that I will promise you'll probably see on your review, on your test, something like this. And this gets a little bit harder just because it's giving you different information, not because it's hard. So find the volume of a cylinder. Stop right there. What's the formula that we're going to use for volume? Say it again. Capital BH. It's the only formula we have so far. So today is easy because we only have one formula for volume. We'll eventually have more formulas. That's not true. We have a volume for a hexahedron or cube, right? Okay. So really we have 2 formulas. Find the volume of a cylinder with a base area of 12 pi centimeters squared. What are they giving me here when they say base area? Okay, which is what in my formula? The capital B. They're giving me the area of the base. So they're telling me capital B. That should make that a little easier. We don't even have to find it. They're telling me capital B is 121 pi. Is everybody okay with that? Base area? But then it goes on to say it has a height equal to twice the radius. Okay, so let's write that down. The height is equal to what? Twice the radius. So h would equal what? 2r. Okay, so here's the problem. We don't know the radius. We need to find the radius so that we can find the height. We do already know capital B, so all we need is the height. So think about capital B and the fact that we have a cylinder. Nope. So look at your cylinder. What is the area of the base, capital B? Okay, 121 pi, but what is the shape of capital B? Circle. What is the formula for the area of a circle? So they're giving me the 121 pi, but I'm going to have to work backwards to find the radius, so I need to use that and plug it in equal to the formula. Okay, so what am I going to put in the place of capital B in order to work backwards and solve for R? What's the formula for capital B? What's my formula? Pi r squared. It's a circle, so the area of the base is pi r squared. So we're going to do pi r squared equals 121 pi. Are you guys with me on what I'm doing here?
Yeah.
Okay, so now we just want to solve for r. What do I do to solve for r? Before I can't take the square root yet. I have to get what's being squared by itself, so I have to divide by pi. Always get what's being squared by itself before you take the square root. Now we have r squared equals 121. Take the square root. What's the square root of 121? 11. So now, if the height is twice the radius, and the radius is 11, what's the height? 22. So we can plug that in right here and get 2 times 11, which is 22. So we just had to work backwards real quick to figure out our radius. And then once we found a radius, it's really easy to find the height. So let's plug it in. What was our capital B again? 121 pi. They gave that to us. And the height we found to be 22. It says give your answers in terms of pi and rounded. So again, 2 answers. What's 121 times 22? 2,662. Pi, don't forget your pi. And units? Centimeters cubed. That would be one of our answers. Then go ahead and multiply it by pi and round to the nearest tenth. What do we get? 8,362.9 centimeters cubed. Everybody agree with that? Okay. All right, the last couple problems that you're going to, or the next couple of problems you're going to see are going to go back to in the chapter 10 when we talked about our shortcuts for describing the effect of change. So let's review our shortcut formula that we had last class period. We said, and I'm only going to review one of them because only one of them is what we need. We said, and you may want to write this down, if all dimensions are multiplied by A, all dimensions, then the perimeter or circumference is multiplied by what? What did we say last chapter? By A. And the area is multiplied by, good Corbin, A squared. You guys remember this? If all dimensions were multiplied by A, the perimeter or circumference was multiplied by A, the area was multiplied by A squared. So what do you think the impact will be on the volume? A cubed. So what we're going to add for this chapter is, if all dimensions are multiplied by A, then the volume is multiplied by A cubed. So that then this becomes super easy and you don't have to work on the long way, but remember that you can. If you aren't sure and you get confused, you can find the volume of the original shape, the volume of the new shape, and take new and divide it by old. Or look at the next example. You can use the shortcut. So it says find the volume of a cylinder. Actually, not that's the same one. Just kidding. How about this one? The radius and height of the cylinder are multiplied by 2/3. Describe the effect on the volume. So first of all, I want us just to look at, are we multiplying all dimensions? So let's look at the formula real quick for volume. What's the volume formula today? BH. Okay, look at your cylinder. What is the shape of the base? Circle. What's the area formula for a circle, capital B? Pi r squared. And then we have that multiplied by the height for the formula. So what are the different variables that are in our formula? R and H. So if it says the radius and the height are multiplied by 2/3, are we multiplying all of the dimensions? Because all we have is a radius and a height. So if all dimensions are multiplied by 2/3, that's our A. Then what should happen to the volume according to our new shortcut today? It should be multiplied by 2/3 cubed. And you need to physically do 2/3 cubed. Don't write your answer as the volume is multiplied by 2/3 cubed. Cube it. So you would say, and it has to be a complete sentence, the volume is multiplied by, and then we will do 2/3 cubed. So go ahead and do that. What is 2/3 cubed? Easy way to do it is just to do 2 cubed and then 3 cubed. So what's 2 cubed? 8. And what's 3 cubed? 27. So we would say the volume is multiplied by 8/27. And that's all you have to do. Does that make sense? What would happen to the surface area? It'd be multiplied by 2/3 squared because it's an area. Okay, so if they asked us about surface area, we could just say it would be multiplied by 4/9 because that's 2/3 squared. Okay, try one more. Same idea, except this time we have what shape? Rectangular prism. It wants to know what happens to the volume. So once again, volume is capital BH. But now the base shape is what base? What shape? It's not a square because the dimensions aren't the same. It's a rectangle. And how do we find the area of a rectangle? Base times height, or they're going to use length times width now because we have another h height for the height of the prism. So we have length times width times height. It says the length, the width, and the height are all doubled. Are we changing all of the dimensions? Because it has a length, a width, and a height. So if all the dimensions are multiplied by, what's doubling? Multiplying by 2. Then the volume should be multiplied by 2 cubed. What is 2 cubed? Nope, that's 2 times 3. That's 2 times 2. It's 8. 2 cubed means 2 times 2 times 2, 3 times. Or type it in your calculator to check. So your answer needs to be a complete sentence. The volume is, do not use a little x. I wrote on your homework last time if you were doing that. The volume is multiplied by, use the word multiplied, 8. 2 cubed is 8. Easy enough? Questions? Okay, I'm not going to work it the long way. If you're having trouble, come see me separately and we'll do it the long way together. But this should be really easy if you just memorize that one little shortcut. Okay, last 2 problems on your homework are dealing with composite shapes. We're not going to work through these, we're just going to talk about them. So I need your attention. It says find the volume of this composite figure. What shapes are in this composite figure? Okay, I heard triangular prism, very good. That's the one that most people make a mistake on. The 2 parallel congruent bases are triangles, and this would be the height between them. So we have a triangular prism. And then what's the other shape? Rectangular prism. If I want to find the volume of this composite shape, what am I going to have to do? Find the volume of each one and add them. So all you would have to do is find the volume of the top shape, the volume of the bottom shape, add them together. That's all. That's a lot, but we've been doing this all morning long, right? So I'm not going to work it again. You would find the volume of the top and the volume of the bottom. Notice something about the triangular prism, though. This is 8. This distance is 8. So what does that make this distance? 8. And so if this is 8, what does that make this distance? 8. So what kind of triangles do you have? Equilateral. So it'll make finding the area of that base pretty easy. You can use that s squared square. It's 3 over 4. What's the height of the triangular prism? 5. Be careful. It's the distance, or excuse me, it's not 5. What's the height of the triangular prism? 4. It's the distance between those two triangular bases, which turns out to be 4. Be really careful with that. And then the rectangular prism, I know you guys would be fine with that. 8 times 4 for the base, and then 5 is the height. But that triangular part gets a little confusing. Any questions on that one? Okay, look at the difference between that and the last one. What are we going to do different with the last one? You're going to subtract. Notice it's hollow in the middle. That's saying you're taking out that shape. So first of all, what's the big shape? So you'll find the volume of the cylinder, and you'll subtract the volume of, what's the shape inside? Is it rectangular? It's actually a square prism. It's going to be a square prism. And just really quickly, I think you can work most of that okay, but the only thing that would concern me would be the square area. So it's kind of hard to see here. Let me move this. This distance right here is 3. What is that representing in terms of the cylinder? The radius of that base. So that'll be easy. And what's the height of the cylinder? 5. It's the square prism I worry about. So to find the area of the square, you're going to need to know the side length, right? So what is this whole diagonal here? 6. Keep in mind, if this is a square, what do we know about this side and this side? They're the same. So one way you could work that would be to use Pythagorean theorem. This is 6. What would we call these two sides? X and X, because they're the same. Do you guys see that? And then you could do x squared plus x squared equals 6 squared and solve for x. What's the height of this square prism? It's also 5. Okay? So if you get to composite shapes, you're going to have to think about it a little bit. Call me or text me if you have questions. I'm not going to lie to you. This homework's a little long, but we're going to do the first 3 really quick together. So that only leaves you with 10 problems. But, guys, listen to me. You do not have room unless you write small and neat, and I need to be able to follow your work to show all of your work on here. It's going to be better for you to do your work on a separate sheet of paper and then put your final answers back on the worksheet. Okay? There's a lot of work to show. We're going to do the first 3 together before you leave, though. So it's just this worksheet. There's 13 problems, and we're going to do 3 together. Which won't make it as bad. Just watch for directions that say volume and surface area. Make sure you're finding both things if it says to. First 3, look at them together with me. The first 3 are wanting you to come up with a separate formula They're asking you basically to plug in what you need for capital B, capital P, and H to write a new formula. So number one wants you to write a formula for the surface area of a cube with a side length or edge length of S. We didn't write a special formula for that. You don't have to memorize a special formula for that, but you are going to have to develop it right here for this homework problem. So surface area we learned today is what formula? pH plus 2B. Okay, so we're going to plug in the information here to come up with a new formula for surface area for a cube. If we're dealing with a cube, what's the base shape? The base shape is a square. What's the formula for area of a square? Side squared. What did they say the side length was called? S. So this is our capital B. So we're going to put S squared in for capital B, multiply it by 2. Now we need to find capital P. How do you find the perimeter of a square? 4S. So they said the side length was S, so we're going to plug in 4S for the perimeter. And what's the height of this cube if the side lengths are all S? S. Okay, now we're going to simplify that. Everybody with me on capital B and capital P? Good, okay. So what is 4S times S? 4S squared plus 2 times S squared is just 2S squared. So add them together since you both have S squareds and we get 6S squared. Think about that with me. If you have a cube, how many squares do you have? 6. And the area of each one is S squared. So you get 6S squared, and that's the surface area for a cube. Does that make sense? Questions? Okay, I expect to see work, not just an answer on your worksheet. So make sure you did it on a separate sheet of paper or showed your work on there. Number 2, surface area for, I don't want to erase that. Surface area for a prism. This time it is, any prism. So we already know this. What's the surface area of a prism with a base area of B and a height of H? Surface area of any prism. pH plus 2B. There's nothing to do there. You're just plugging in that formula. pH plus 2B. Because it just said a prism. Any prism. Okay, the cylinder is going to be different. We're going to actually come up with the formula for the cylinder. I told you to use capital B, surface area pH plus 2B, but we can simplify that since it said specifically a cylinder. So surface area is capital pH plus 2B. Since it's a cylinder, what is the base shape? A circle. So what is our formula for area of a circle? Pi r squared. Okay, it said a cylinder with a radius of r and a height of h. So we're still just going to leave this r for radius and the height is still h. So the pi r squared is going to go in for b times 2. We still know that h is h. They didn't change the height. How do we find the perimeter of the base? It's a cylinder, it's a circle, which is circumference, which is 2 pi r. And they said the radius was just r. So we're going to plug 2 pi r in for perimeter. Since this is 2 pi r h, there's really nothing we can do besides just write 2 pi r h. Nothing can really be multiplied or simplified. Same thing here. This is 2 pi r squared. There's nothing we can really simplify. So this is the formula for surface area of a cylinder. Now, I don't have you memorize it that way. I just have you do pH plus 2B, find your base, find your perimeter, plug it in. But you could memorize that if you wanted to. Okay? First 3 are done. You're doing the other 10 just like what we did in the notes. If you have questions, Encore is free tomorrow, Wednesday. Some of you may have assigned Encore, so make sure you check. Because I assigned a lot of Encores for this week. You're welcome. The bell's getting ready to ring, so make sure your calculators get put away, please. And you should have mandatory CAP Encore today in case you aren't aware. Make sure you go see your CAP teacher. Have a great week.